Welcome to solverfy.
.46, we're told that low-pressure sodium vapor lamps have an emission spectrum that has well-defined wavelengths, but a high-pressure sodium vapor lamp has lines that are sort of more spread out or wider or what have you. And we want to talk about the relationship of this to the sort of continuous smear of wavelengths you get by a solid. And so in the high-pressure lamps, the atoms are much more closer together. And so you're going to get some of the sort of interaction you see between the atoms as you would in a solid. Solids have continuous emission spectra because everything being so closely packed together means that there are a lot more energy levels that a given electron has to choose from, because not only does it have those of its own atom, it also has sort of those of the entire solid considered as a whole object. And because things are sort of, there's much more room for things to move around, and there's multiple atoms that things could move between and so forth, you get an infinite, basically, number of energies that the electrons can have. Found in solid. And it turns out that, and this makes sense, that this sort of isn't an effect that like turns on instantly when you go from a gas to a solid. I mean, first of all, because there are liquids in between. But generically speaking, as you sort of pack atoms closer together, you get this broadening of the spectral lines until you get a solid where they all smear together into a continuum.